All right, the next big issue we're going to talk about in the field that's on your next outline spot is the field of psychopharmacology. My English teacher at The Ohio State University, national football champions, basically always said to me, you always have to ask the question, who cares? And so as we're covering all this stuff on chemistry and electrophysiology, the question of who cares kind of comes to mind, and the answer to that is, well, a lot of people would care about all those steps with neuronal communication because drugs affect that whole process. So the field of psychopharmacology, how do drugs, pharmacology, affect behavior? One of the biggest issues in regards to this is this issue that we talked about in the first part of the presentations, which is reductionism. The idea of, can you just take a drug to fix a behavior, a mental state? In fact, I was on my bus this morning talking with somebody as I was taking the city bus downtown here in Roanoke, and the guy said to me, I took this drug, the doctor said it would just help me with sleep, but I was reading up and it looks like it also helps with depression. And so the idea there was very much based on reductionism. The drug was actually trazodone. And trazodone is, in fact, a drug that affects serotonin systems. And so the idea of, well, if serotonin is linked to just sleep, then increasing it will help improve sleep quality. But serotonin can also be reduced to depression. So it might not be a type reductionistic idea. But the idea of, can you have a designer drug that just fixes the problem that you want and doesn't cause any side effects is a big deal. So we have a way of classifying different drugs. They're either called in psychopharmacology agonist or antagonist. And one example of a simple agonist is if you've ever heard of the disease Parkinson's disease, that many times people take a product called L-DOPA. And L-DOPA is converted into dopamine by the brain. It gets through the blood-brain barrier and then will be converted into dopamine. That's actually considered a dopamine agonist. It mimics what dopamine does. There are other drugs that you can take, some of them for schizophrenia actually, that tend to block dopamine at the binding site. And so a lot of the drugs that are used for schizophrenia, I think one of them is clozapine, C-L-O-Z-A-P-I-N-E. It's actually a dopamine antagonist. It blocks the binding. So drugs can be either classified as mimicking the neurotransmitter, which would be like, what did I say? L-DOPA helps with the synthesis, or another drug that's an antagonist like clozapine, which blocks dopamine receptors and will help with schizophrenia. So that's the first part of the psychopharmacology. The other issue, and you can see it in the drawing below there, is this issue that's become very important. It has to do with receptor subtypes. Now, let's talk about the category that we know as behaviorally pain. Pain is a very multidimensional thing, isn't it? And as it turns out, there are a lot of receptors in the brain that have pain, or we should say endorphin-based receptors. So we know the neurotransmitter are called the endorphins, and it turns out there are a lot of different receptor subtypes in the brain. You can see there's a beta endorphin, a mu endorphin. I can't even read some of the other ones, but they're all Greek letters, so I guess I could say it's Greek to me. There are these different types of receptors. So receptor subtypes are different shaped receptors. And if you look at them here in the brain, it looks like even for the endorphins, there are different receptor subtypes. So the question that a lot of people want to know is, what is the functional significance of these receptor subtypes? Meaning, do different receptors have different properties? So the idea is, when you take a product like morphine goes in and it probably binds to all of these receptor subtypes. And thus, it'll help with pain. But if you know anything about morphine or Demerol, there are also a lot of side effects. And what is hypothesized is that the reason you get all these side effects is because these product like morphine does affect pain in a structure called the periaqueductal gray, but it also is causing side effects by affecting other receptor subtypes in these other areas. So sorry about that, I had to pause for just a second here, but the idea is when you take a drug like morphine, it's actually affecting lots of different areas, so it'll help fix the problem you want with pain, probably in the periaqueductal gray, but it'll also cause a lot of side effects because the morphine that you're taking is probably binding in a lot of those other subtypes. And by binding in the thalamus and the hypothalamus, it's probably causing some of the effects with things like constipation, change in eating, change in body temperature. And so what the pharmacology companies are really trying to do, the pharmaceuticals, can you find a product that'll just bind to the periaqueductal gray receptor subtypes, maybe fix pain, but not cause all the side effects? So that's the issue of receptor specificity. Can you have receptor specificity and behavioral specificity? The other thing that I'd like you to do is consider Roman numeral 5 here, where it goes over depression. The same kind of idea in terms of receptor specificity here. The first drugs used to treat depression were called monoamine oxidase inhibitors. And these products, like Nardil, they work to block serotonin and some other things, but look at all the side effects if you ate the wrong things. So these were very non-specific products. Now we go into something like Paxil or even Zoloft. They are more specific, focusing in on blocking the reuptake of serotonin, but they still have some side effects. And notice that they also fix other disorders as well, so maybe not type reductionistic, but maybe related to token reductionism. And then we get even more designer products like Effexor, which help out with serotonin and dopamine by blocking the reuptake. So they're considered serotonergic and dopamine agonists, more specific. So the better the drugs are they more receptor specific and then behavioral specific? The older drugs tend to be more general and not specific, and so there are a lot of side effects for them. So hopefully you can type up the notes and in your own words share this with the main ideas here. Thanks. Bye-bye.